Good morning to everyone. My name is Ganesh from VVT College in the Department of Electronics and Communication Engineering. Today I am here to present a seminar on signal systems. This seminar is aimed to giving a clear understanding and fundamental concepts, practical importance and application of this topic. I will cover the subject in the structured way, starting with the basics, moving into detailed explanations. Let us begin. We have conducted that introduction of signal systems and classification of signal systems. Here, introduction of signal is one of the part of signal. First, we have to discuss about introduction of signal. A signal is a function of a physical quality that varies with time, space, any interaction, independent variable, and which carries the information. Signal is a form of waveform where varies with time in any amplitude or space or any region in a particular time period. It has aperiodic and periodic. Examples: voice signals, ECG signals, and voltage waveforms, etc. They are divided in electrical engineering, voltage and current varying in time. We have seen that in the some of the experiments where voltage and current are the graph between, then waveform will be varying in time with changing of current and voltage is increases like current is increases, voltage is decreases like this is the waveform where we are represented in lab practicals. In communication, voice or image waveforms. In medicine, ECG and EEG signals are the applications in medicine. There are some basic signals we have discussing about here. Sinusoidal signal, it is in the form of x of t is equal to a cos of omega t plus pi. But here sin of omega t plus pi is the correct. It is a mistake, and it is periodic with time period. T is equal to 2 pi by omega. Here omega is the angular frequency, and pi is the phase. T is the time period. It varying with 2 pi by omega periodic. It is like sinusoidal waveform. This basis for Fourier analysis. Any signal can be expressed as the sum of the sinusoids. Another one signal is exponential decay signal. This signal in the form of x of t is equal to amplitude a e power bt. Here b is the constant and a is the amplitude. E power is exponential. If b less than 0 means it is the negative number, but b belongs to set of real numbers where 0 minus 1 minus 2 and and corresponding to 0.001 and 0.0001. All decimals values are also included. Exponential raised signal also one of the variant, but in this form, the constant b is greater than 0 means positive values. It belongs to set of all real numbers. It consists of 0.001 and all decimal values in positive numbers. Exponential decay is negative numbers. It is in the form of same form amplitude a into e power bt. Here b with change in decay minus b and rise plus b. It is the difference between exponential. And next is unit step signal. Unit step signal is form of u of t is equal to 1 or 0. 1 for t greater than 0 means t is positive. Then unit step signal is raised to 1 in the graph and 0 for t less than 0 means for a negative values unit step signal is not defined. It is equal to unit impulse signals. It is a form of del of t is equal to 1 for t is equal to 0 and 0 for not t is equal to 0. T not equal to 0. It is a area is equal to 1, but it is shown like vertical line in the graph. It is 1 for t is equal to 0, where t not equal to 0, it is does not define. It has property, the sampling property, very useful in analyzing systems, where it is also called as impulse response, used in Fourier transform applications. And an introduction to systems. A system is a physical device or mathematical model that possesses as input signal and produces as output signal. It is the interconnection of input and output. It is a system where changes input to output. Example, amplifiers, filters, communication channels, and etc. Where we are using these applications in real life, that for for changing the modulation of the frequency and changing the voice to raise and slow and travels for all applications. There are some standard examples of systems. In RC means resistance and capacitor circuits. Input is voltage source and output is current through capacitor. System type linear and time invariant and causal stable dynamic systems are these are examples. Behavior is act as low pass filter. In RL circuit means resistor and inductor circuit. Input is voltage source, output is current through inductor. System type linear and time invariant, causal, stable, dynamic. Behavior is act as a high pass filter. It is the main difference between RL and RC circuits. Ideal definition letter. Input x of t, output y of t is equal to dx of t by dt. It is the difference between if we given input as a x of t, the system changes to y of t means output like derivative of x of t. Its derivative is the system. So ideal definition of the system. Ideal integrator is same as if we given x of t as an input and output give us y of t, where the system is integrator. So input must be integrated, so output in the form of y of t. Here in ideal difference letter, system type is linear, time invariant, and dynamic causal. Here ideal integrator, system type is linear system, time invariant system, dynamic system, causal system. We will run to second topic, that classifications. One of these classification of signals is there are some signals, continuous and discrete time signal. It is continuous time signal. It is defined for every instant of time. Continuous time signal is the time variable is only integer value in the real numbers, where 0, 1, 2, 3, and so on, but not decimal value. For discontinuous time signal is defined only at particular instant of time, where it is also called as discrete time signal. Discrete time signal means for all real values where decimal 0.001, 0.01, 0.23, and so on. It is only at particular instant of time. Deterministic and random signal. Deterministic signal is a specified in time, mathematically represented. For random signal is random in nature, mathematically cannot represent it. Where it is in random, all values in random in nature, so we cannot represent it. Periodic means you know that it is repeats in the interval of time. For any instant of time, the same values must be come to the next periodic, where it is called as periodic. The periodic is cannot repeat the same pattern in the interval of time. It is irregular in time, even and odd sequence, even signal. The signals are exhibit symmetric properties in time domain, where for a y-axis it is symmetric to the positive x-axis and negative x-axis, where it is represented as x of t is equal to x of minus t. Odd signals. The signals are exhibit anti-symmetric properties in time domain. X of t is equal to minus x of minus t. Here the difference is for x of t is equal to x of minus t. For positive and negative values of x is equal to the amplitude in the positive y-axis. But in odd signals, positive x-axis and positive y-axis is equal to negative y-axis and negative x-axis. It is the difference between the even and odd signals. Energy and power signal, where energy signal is a energy signal is a different to the power signal. We have discussed in later classification of systems, continuous and discrete time signal. We know that in a classification of signals, they're same as this. In this systems and there is signals. There are two types. A continuous time system. It is a system where input and output are continuous in time. All values where with respect to only one or two, it is dispersed also. Discrete time signal is only integers 1, 2, 3, 4 only. For causal and non-causal systems, it is a system whose output depends on the past and present input but not on future inputs. Non-causal systems, it is system whose output depends on future inputs but not on past and present inputs. Linear and non-linear system. Linear system. A system is said to be linear. It satisfies Sohn-Wilson theorem. Non-linear system. A system is said to be non-linear system. It does not satisfy Sohn-Wilson theorem. There are in another two types, time variant and time invariant. Time variant system. A system is said to be time variant if its behavior or input and output characteristics change with time to same respective time. Time invariant system. A system is said to be time invariant if its behaviors, input and output characteristics do not change with respect to time. Memory system, non-memory system. Memory system, the system which depends on input from past and present of time. Non-memory system, the system which depends only on present time values and does not depend on the past. Conclusion. We have discussed about introduction of signals and introduction of systems, and it has classification of signals and classification of systems. A signal representing information by system process signals. Signals can classify into continuous time and discrete time, analog or discrete or periodic or period, deterministic and random, or energy or power, etc. System are classified based on linearity, causality, stability, memory, and time variance. Understanding this concept is crucial because serve as the backbone of electronics communication and control in any field too. Thank you for everyone.